Hello everyone, welcome to Mathematics Unit 2. Today we're going to focus on your notebook part B, the application of rate of change. We have three success criteria today. The first one is I know the difference between average speed and average velocity. This is something you probably did in year 10 science, and so today we're going to quickly go through the difference between these two terminology again. And the second success criteria is I know how to interpret and interpreting position and time graph and also the velocity versus time graph. And the third of all, we also need to know how to draw the velocity versus time graph. Okay, so first of all, let's back to this first success criteria. I know the difference between average speed and average velocity. Okay, so back to our science, we know for moving particle, the speed is equal to distance over time. Okay, and the velocity is actually equal to position. So equal to position, change in position. Okay, or we'll say change in position, over time. Okay, these two things are totally different things. Okay, so let me give you one example. If I have one particle that going from A to B, okay, so the distance is 10 meters. Okay, we have a point that is in the middle, that is C. Okay, so here that is 5 meters, that is 5 meters. So in total between A and B, the distance is 10 meters. Okay, so let's see, a car is moving from A to B. Okay, and then so a car is moving from A to B and back to C. Okay, so the total time for this whole thing, let's say it's 3 seconds. Okay, so now the speed for this situation, speed is equal to distance over time. So that will be distance. So we have A to B and B to C. So that is 10 plus 5. That's my total distance. That is equal to 15. Okay, equal to 15. So therefore total distance is equal to distance is equal to 10 plus 5 equal to 15 meters. So therefore that is 15 meters over straight. Okay, so my speed is 5 meters per second. This is the speed, okay, the distance. Now when we're talking about velocity is equal to change in position over time. What do we mean by change in position? That is referring to starting point. So therefore, even though I start from A to B, and back to C, but the position I got, so here is my stopping distance. So where I am compared to my starting point, that is my, so maybe it's a different color. This is my changing in position. Okay, so this change position is how far it is comparing where you start. Okay, so even though you go to B and then you back to C, but when you stop at C, where you are is 5 meters away your reference point, the starting point over here. So your change position is actually equal to 5. So therefore your change in position is equal to 5 over straight. Your velocity is 5 over straight meters per second. Okay, so now you see the difference between average speed and velocity. It's all about whether it's we are talking about the total distance and change in position. All right, so let's back to your example part B. So part B, if you, now I will just leave this example to you to do it. Okay, So I just leave this example for you to do it. If you're not sure how to do it, just check example 2 of your textbook, chapter 16, example 2, sorry, and then the textbook will tell you how to describe this motion. Okay, now coming back to over here, so example B, we have the graph below show the motion of two cars. Example B over here, the graph show the graph shows the motion of two cars traveling in a straight line away from a fixed point. Oh, okay, so we're starting from here, O, and where D is the distance traveled at time, okay? And then so this one is proof that the car is moving at the constant speed with 16.7 meters per second. So now we know, so this is talking about speed. Speed is equal to total distance over time. So average speed is equal to distance over time. So the total distance, let's just try to look at the part from here to this point. So total distance is 500 over time is 30. That is 30. Therefore, that will be meters per second. Now 16.7 meters per second. Right, and we can do what we can do over here is, if we want to, this is annoying, calculate the average speed from the car over the time interval. Okay, change this from 15 to 30. Okay, so now the curve ABC, now we are just trying to find the average speed. So average speed is equal to distance over time. So distance, now you see over here, so if I draw a line here, the distance we run from A to B is this part. This is my distance, which is 200 minus 100. Okay, and then total time is here. Let me use a different color. Is this part, which is 30 take away 15. Okay, so basically we are, so if I write the coordinate pair of B, that's 30, 200, and this is this point is 1500. So basically we're trying to do rise or run, so because distance is 200 minus 100, that is actually our rise, and time is 30 take away 15, that is actually run, the horizontal cross run. So you have 100 over 15, you have 6.7 meters per second. So now have a look at this curved AB. When we find the average speed, we actually find average rate of change, because rise over run, that's the average rate of change between A and B. So back to our notes. So if we have a graph that is position over time, okay, so that is my right. Okay, so if we are trying to find the gradient, okay, so gradient here, this part is the change in position, this is change in time. So if we're doing rate of change, that is equal to change in position over time, which is our velocity. So therefore, if we can have a conclusion, in conclusion, the velocity is the rate of change on the position versus time graph. Okay, so for example, if I have a graph, this is position, this is time. So now if I have a graph like that, so now I know this rate of change. So now, because this is 1, 2, gradient 1 is larger than gradient 2. So I know A, B, so the velocity of 1 is larger than velocity of 2. Okay, so this is the relationship between the position and position versus time and the velocity versus time graph. So make sure you know this part. Now, so coming back to our example, okay, so this one I'll also leave you to do it. Now let's do this velocity and graph. Now this graph show a position. That position and time. Okay, so we know the gradient of this will be the velocity. Okay. So the road runs north to south, and the north is choosing as a positive direction. Draw the corresponding velocity to time graph. So okay, let's do this. So this is my velocity, this is my time. Okay, make sure what's the unit. Velocity is kilometers per hour, this is hour. Okay, now let's do 0 to 2. 0 to 2, this is a straight line, so I can find the gradient. Okay, so the gradient is equal to rise over run, which is equal to, so this point is 2 and 20, this is 0, 0. So rise over run, that is 20 minus 0 over 2 minus 0. So it's 20 over 2 is 10 kilometers per hour. Because this is straight line, so this means my graph is moving with a constant speed, velocity, which is 10 kilometers per hour. So let's do, so therefore that will be, So you have that is 5 kilometers per hour, and that is 10. So initially 10 kilometers per hour. So initially 0 to 2 meters to 0 to 2 the second hour. The speed is consistent 10 hours per 10 kilometers per hour. Okay, so that's the first one. And then let's come back. Let me use a different color. So now this one. So let's find the gradient. Gradient is equal to rise over run. So that is 4 negative 10, that is 220. So gradient is equal to negative 10 minus 20 over 4 minus 2. The gradient is negative 30 over 2 is negative 15. Okay, so now it's negative 15 speed. Okay, so 5, 10, 15. So therefore that is negative 5, negative 10, negative 15. So 2 to 4, you have a speed that is negative negative 15 kilometers per hour. Okay, so if it's positive, that means we're going to north. Okay, because we say north is positive. So therefore, if we have negative, that means it's going to south. Okay, now let's continue. Now we have this part. Let me use a different color again. Maybe use red. So this part, the fourth part to the fourth hour to the fifth hour. So we're gonna do the gradient. The gradient for this part is 5. So the point over here is 5 and 0. Okay, so the gradient therefore is equal to 0 minus negative 10 over time 5 minus 4. So you have 10 over 1, which is 10. So therefore the fourth to fifth hour, it's positive 10 kilometers per hour. So this positive means it's going to the north. Okay, so that's how you do it. Now this one, example B5, the position of particle is moving a straight line. It's given by the function. Okay, so this is tell me where the particle is in regards to time. Okay, so initially we are going, so you see the distance at the fourth, I don't know, it's hour or okay, when the time is equal to 4, the distance of the particle is negative 30 meters compared to the original where the point start. Okay, so now this one is find the average of the particle. Okay, so now let's do, we know average velocity is the gradient of s versus t graph. Okay, so this is my s to t. So 3.5 is over here and 4.5 is over here. Okay, so therefore we need to find, maybe it's a different, we need to find what's the average rate of change between these 2 points. Okay, average rate of change. So that is my run, that is my rise, that is my rise, that is my run. So therefore we need to find, so this point is when t is equal to 4.5, you need to find what is the space by substitute 4.5 into this equation. And we also need to find this point when time is equal to 3.5, and you need to substitute into the function s to find what is the position. Okay, so when t is equal to 3.5, s 3.5 is equal to 3.5 cube minus 6 times 3.5 square, you will find it is negative 30.625. and then when t is equal to 4.5, s 4.5 is equal to 4.5 to the cube 6 times 4.5 square, you will find that is equal to negative 30.375. So then velocity, average velocity, which is the average gradient between these 2 points over here. So therefore average velocity is equal to the average rate of change, s 4.5 minus s 3.5, 4.5 minus 3.5, and then you'll have, so negative 30.375 minus negative 30.625 over 4.5 minus 3.5, and then it is equal to 0.25. So therefore the velocity at when t is equal to 4, so the average rate of change is 0.25, and now we can make the point smaller, so 3.9 and 4.1. So you see these 2 points are very close to the point that when t is equal to 4. So you're going to do the same thing eventually. So find t is equal to 3.9. What's s? 3.9. And you need to find what is the distance when t is equal to 4.1. So eventually you'll find average average velocity is equal to s 4.1 minus s 3.9 over 4.1 over 3.9. It is equal to negative 1. Okay, so this is the average rate. And then we can make it the number even closer, 3.99. So 3.99 is over here, and 4.01 that. So these two is so close, they kind of overlapped. But you're gonna do the same thing, and then eventually you will find average rate of change, average velocity is equal to 0.0001. So you see this is actually the speed, but then it's not overlapped, but ideally to this extreme point, when t is equal to 0, as the position should be equal to 0. That's why you say velocity and t, when t is equal to 4, the extreme point, your velocity is actually equal to 4. And that come to the answer over here. For part A, what is the instantaneous rate of change? Because when the 2 points overlap, that average rate of change is your instantaneous rate of change when t is equal to 4. So which is 0, 0. Okay, so instantaneous rate of change is velocity is equal to 0 kilometers, 0. Okay, now so what value of t is the velocity? That is the positive. We know velocity is the gradient. Okay, it's the gradient. So if we draw the gradient, okay, let me redraw the graph over here. So because your graph, the graph overall is this. Okay, so your graph, okay, this graph is, so you have like that. This is equal to 4, this is equal to 6. Okay, so this is my position and time graph. So we know the velocity is the gradient. So therefore, and I know the gradient is over here, which is a negative gradient. Okay, so this part is negative gradient. So therefore, this is when t is larger than 0 and smaller than 4. That's the gradient is negative. When we have a positive velocity, which is positive gradient, which is this part, see all the gradient is positive. So therefore, this part is when t is larger than 4. Okay.